right, so hopefully you've had time to do C, D, and E, and let's try that on our own. So first of all, I'm going to see that x squared minus 4 is a difference of two perfect squares. So I have an x plus 2 and an x minus 2. And then over here, I see that this is backward. So the first thing that I'm going to do is I'm going to make it an x squared minus 4. And the negative that I just factored out, I'm going to make that a plus. And so now I see that I have an x squared, or an x plus 2, and an x minus 2 here as well. So these things are already least common denominators. So all I have to do is I have to add the numerators. X plus 2 all over x plus 2 times x minus 2. And now, once I see those, then I can say, oh, one of those will factor with one of those. But don't forget that when you cancel, you do get ones, right? And what's in the numerator has to stay in the numerator, and what's in the denominator has to stay in the denominator. And so what I get here is 1 over x minus 2. It's very common for me to see students write this answer as simply an x minus 2, period, end of sentence, which is of course wrong because what's in the denominator then just came up into the numerator, which isn't really a correct answer. In fact, not really a correct answer. It isn't a correct answer. All right, now the next one, we have another issue here. We have a whole number, and remember, whole numbers go over 1. So our least common denominator here is going to be the y plus 3. So this y plus 3, which is our least common denominator, we're going to have to multiply here, and we're going to have to multiply here. And that means I'm going to change this to add the opposite here so I can get this negative 2 distributed through. So I'm going to have y plus 2 over my least common denominator, and then plus negative 2y minus 6 over my least common denominator. And now I can combine my like terms. I have a y and a negative 2y, which makes a negative y. And then I have a 2 and a minus 6, which gives me a minus 4. And then that's over my least common denominator. And now the next thing I might see is that these are both negatives, right? Leading coefficient being negative. I want to factor that out. So I'm going to factor out a negative, and that's going to give me a positive y and a positive 4. And now I'll bring back in my least common denominator, that y plus 3. Now, some of you may never have taken the least common denominator out, and you may have been writing along as y plus 3 all along, and that's fine. It doesn't matter. And remember, there's no canceling in addition, so these y's here can't cancel out or anything. Pardon me. So all you have is an opposite, or a negative, of y plus 4 over y plus 3. Now moving along to part E here. First things first, we need to factor. So we have an x plus 1 and an x minus 1 because the difference of two perfect squares factors into the product of their conjugates. So the root here and the root here forming those conjugates. And then this next one, x plus 1, or x squared minus 2x plus 1, that's a perfect square trinomial, which factors into the roots of the constant and the x squared term. The sign in the middle comes here, and it's squared. So my least common denominator this time around is going to look like an x plus 1 times an x minus 1, and the highest exponent on the x minus 1 is a 2, so it's an x minus 1 squared. Now I'm going to change this to plus a negative 2 so that I don't make any mistakes. So what I'm asking myself is what's missing from x plus 1 times x minus 1 to make x plus 1 times x minus 1 squared? Well, of course, an x minus 1 is missing from there. I have one factor of x minus 1 missing. So I'm going to rewrite that and multiply it by there. And then I ask myself what's missing from x minus 1 squared to give me x plus 1 times x minus 1. So x plus 1 is missing this time around. And so I'm going to multiply both the denominator and the numerator by that so that I get my higher terms. And now I will actually do the multiplication and multiply those out. So x times x is x squared minus x, and then minus 2x, and then minus 2. And all of that is over my least common denominator. Now I'm going to simplify. So these are my like terms here. So now I have an x squared minus 3x and a minus 2. And that, I asked myself, can I factor it? Well, I would need the factors of 2 that gave me a difference of 3. No, unfortunately, it doesn't factor. They don't exist. So I'm just going to bring in my least common denominator, my x plus 1, and my x minus 1 squared. And I'm going to write that as my final answer. So there we go. That is my final answer. And those are our adding when we have unlike denominators. So hopefully that went well for you and you were able to do those without any problem. And the last thing that I think I'm going to do a small video on is just some translation problems, and so that you can see how we might be using these rational expressions to come up with an expression from a translated problem. So I'll see you in another video.